projects. In this video, we are going to explain about the project titled Graph Convolutional Network based on multi-head pooling for short text classification. The project's objective is to enhance computer understanding of short text messages like tweets or reviews, which are often brief and lack context. Short text is challenging because it lacks enough words for traditional methods to accurately classify it. To address this challenge, the project employs advanced techniques like graph convolutional networks (GCN) and multi-head pooling. These methods help computers connect the meaning of words in short text, providing context. The project's significance lies in its real-world applications such as detecting spam emails and understanding sentiments in social media posts. Accurate text understanding is essential in these contexts. By using advanced techniques, the project aims to improve the accuracy of short text classification, making it more dependable for a wide range of applications. The project's primary aim is to develop computer programs capable of accurately understanding and classifying various types of text data. To achieve this, the project employs advanced techniques like Word plus MB, GCN, GIU, LSTM, RNN, CNN, and BiLSTM, which act as tools to help the computer make sense of the text. These techniques work like tools, aiding the computer in understanding the meaning of words and sentences in text, ultimately improving its ability to guess what the text is about. The overarching goal is to make these computer programs highly proficient in classifying text, whether it's discerning sentiment in a review or identifying the topics within a body of text. Additionally, the project intends to create a user-friendly system where individuals can input text in any language and the computer will analyze it and display results on a website, making it practical for various real-world applications. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements. In software requirements, we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. In this module, the necessary Python libraries and packages are imported. Common libraries include NumPy, Pandas, Scikit-learn, TensorFlow or PyTorch for deep learning, Matplotlib and Seaborn for data visualization. These libraries provide the tools and functions needed to manipulate data, build machine learning models and visualize results. Exploring the dataset R8, R52, OH. This step involves loading and examining the datasets used in the project. 3 datasets are mentioned: R8, R52 and OH. Typically, we would check the dataset structure, view sample record, explore class distribution and understand the features and labels. This exploration is crucial for understanding the data before proceeding with any modeling. Visualization using Seaborn and Matplotlib. Data visualization is an essential step in understanding the data and gaining insights. Matplotlib and Seaborn are popular Python libraries for creating various types of plots and graphs. These libraries can be used to visualize data distributions, correlations, trends, and any other patterns that might be useful for feature selection or model understanding. Label processing. Label processing involves preparing the target labels for the text classification task. Depending on the dataset and task, labels might need to be encoded into numerical format, one-hot encoded, or subjected to other transformations. This step ensures that the labels are compatible with machine learning models. Data processing. Data processing is a crucial step where text data is prepared for modeling. This typically includes tasks like text pre-processing, cleaning and normalizing text, that is, removing punctuation, stop words, stemming or lemmatization, feature extraction, converting text into numerical vectors using techniques like DF-IDF, word embeddings, that is, word to vector, GLOVE, or deep learning based embeddings, that is word to vector. Splitting data, dividing the dataset into training, validation and test sets. Handling imbalanced data. If classes are imbalanced, techniques like oversampling, undersampling or class weighting may be applied. Tokenization. Tokenization is a specific text pre-processing step that involves splitting text into individual tokens, words or subwords. Tokenization is crucial for creating a sequence of words that can be used as input to deep learning models like GCNS. Tokenization libraries like NLTK or SpaceSci can be used for this purpose. Feature selection using Pandas iLog. Feature selection is the process of choosing the most relevant columns from a dataset for a machine learning task. In Python, Pandas is commonly used for data manipulation. The iLog method allows to select specific columns based on their integer positions. Splitting the data to train and test. Data splitting is essential for evaluating machine learning models. It involves dividing dataset into two parts, one for training the model and the other for testing its performance. Building the model, in which we have different algorithms. The first one is BERT plus MP-GCN. This module combines two powerful techniques for text classification. BERT, bidirectional encoder representations from transformers, is a pre-trained language model that understands contextual information in text. MP-GCN, multi-head graph convolutional network, is a graph-based deep learning model designed to work on structured data. In this project, BERT enhances the GCN for improved short text classification. It likely involves fine-tuning BERT on specific text classification tasks and integrating it with the GCN architecture. GRU, Gated Recurrent Unit. GRU is a type of recurrent neural network (RNN) used for sequential data processing. It's often used for tasks like text classification, sentiment analysis, and sequence-to-sequence tasks. In this module, GRU is likely employed as part of model architecture. LSTM, Long Short-Term Memory. Similar to GRU, LSTM is another type of RNN designed to capture long-range dependencies in sequential data. It's commonly used in natural language processing tasks. LSTM may be used as an alternative to GRU or in conjunction with other components. RNN, Recurrent Neural Network. RNN are a class of neural networks designed for sequential data. This module suggests that traditional RNN might also be considered as a component of your model architecture. CNN, Convolutional Neural Network. CNN are primarily used for image analysis, but they can also be applied to text data for tasks like text classification and sentiment analysis. CNN capture local patterns and features in the data. This module involves using CNN layers in your model for text classification. BiLSTM, Bidirectional Long Short-Term Memory. BiLSTM is an extension of LSTM that processes data from both directions, forward and backward in time. It's useful for capturing context from both past and future in sequential data. BiLSTM could be used as an alternative to GRU or LSTM in the model. Training and building the model. The model will be trained to learn the patterns and features necessary for short text classification. The training process may involve optimization algorithms, loss functions, and metrics for evaluating model performance. Flask framework with SQLite for sign-up and sign-in. Flask is a Python web framework used for building web applications. In this module, Flask is employed to create a web interface for users to sign up and sign in. SQLite. SQLite is a lightweight and self-contained SQL database engine. It's often used for small to medium-sized web applications. In this project, SQLite is likely used to store user account information, including usernames and passwords. User input and pre-processing. User input. Users provide input in any language and the system should be able to handle text in various languages. Translation and pre-processing. The user's input is lightly pre-processed for consistency and fed into the model. Depending on the requirements, we might also perform language translation if the model is trained on a specific language and the user input is in a different language. Trained model for prediction. The trained model, which has learned to classify short text, is used to predict the category or label of the user's input. The model's output is based on its understanding of the input's text content. Final outcome displayed through frontend. The model's prediction or classification result is displayed to the user through the web frontend created using Flask. This could be in the form of class labels, confidence scores, or any other relevant information. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. These are the model files which contain algorithm information which will be loaded into the project code during runtime. This is IPYNB file. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address and port. Now copy the local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome. And hit enter. The home page of the project is displayed in the browser. This is the home page. This is the front end built using Flask framework. Now click on sign up button. If we are a new user, we need to register first. But I have already registered, so click on sign in button. This is the login form. Enter the username and the password and click on login. This is the home page of the project. Here we need to enter the message, and after entering the message we will predict the text type. So I am entering the message. So this is the message which I have entered. Now click on predict. So this is the result for the text. The text type is on. So here we have predicted the text type. Now let us enter some more messages and check the text type. So I am entering another message. So this is the message which I have entered. Now click on predict. The result for the text is, the text type is ACQ. Now let us enter one more message. So this is the message which I have entered. Now click on predict. The result for the text is, the text type is trade. Now let us enter one more message and check the text type. This is the message which I have entered. Now click on predict. Result for the text is, the text type is ACQ. So in this way, by entering the text, we can predict the text type. Now click on sign out, and the conclusion of the project is, the LSTM long short-term memory model outperformed all other algorithms, achieving the highest accuracy in text classification tasks, particularly for the R8 dataset. The project successfully tackled the challenges of the selected algorithms, with LSTM leading the way, significantly improved the accuracy of text classification, enabling better comprehension of brief messages. The results have real-world significance, benefiting applications like sentiment analysis, topic categorization, and spam detection. The improved accuracy empowers businesses and researchers to trust automated short text analysis for decision making. Going forward, the project can explore further improvements and new applications for these algorithms. This could lead to even more precise and effective text analysis tools in the future.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.